So we've done that, console instruction set. Also something that's not really a user interface, but I want to mention it. We've also provided the ability to lock a part file with a password inside of NX, so it's controlled by NX. You do not need Team Center for this. In fact, it's done in native. And the files are password protected. They can only be opened inside of an NX session if you have the password.
What happens if you forgot a password?
Then you're hosed. There is a master password which you have to create at the same time. It's a way of overriding, but again, remember it, because once it's encrypted, we can't unencrypt it. We did that on purpose so as to guarantee the security of the files. It's for you to use.
What is it handy? Because
and you can set them to be like read-only. So if I set a file to be read-only and I send it to somebody and say, here's the password for opening this read-only file, when he opens it, it is read-only. He cannot save as, he cannot change the name of it, he cannot save it. He's stuck, because that file is encrypted down to the OS level. Or you could say read-write, or you could just give him full privilege. So those are the things. It's minor, but some people have asked for it. And after we showed it to the beta testers, they said, give us an option for turning this feature off. We don't want to give people the ability to encrypt all the files in the system and then walk away with the password. So it will be under the control of the administrator. Okay. While we're talking about interface changes, this isn't really an interface change, but it is a change in something that we hope everybody's using, and that's a sketcher. So I'm going to create a new sketch, and I've decided I want to draw a couple of lines, and I want to draw them in such a way that the endpoints of these lines stay lined up to each other, like that. More interesting is a situation where I want to draw a circle, and a circle, and a circle, and then if I move one of the circles, I want the others to go with it. Or I want to draw another circle. So if I move this one, see, that one goes that way, and so on. Now, you can do this today, but you got to draw extra geometry. Draw a line, constrain all the circles to be on the line, and then probably turn the line into a reference curve because you don't want it part of your profile. What we've added is a new constraint called horizontal and vertical alignment. Don't confuse this with horizontal and vertical lines. That's different. This is simply the alignment of points. It can be the centers of arcs, endpoints, midpoints. Any point can be aligned to another point, whether it's a point or a virtual point. And it's just like anything else. I can create them either on the fly like you saw me do there, or I can do it afterwards and say, gee, I'd like to have these two line up vertically, so now they line up vertically. So this is a new constraint type. Now, we've also added the ability, let's say I've got a line here, let's say from here to here, and I want to dimension this line in such a way that I'm dimensioning half the line. So I'm going to put a dimension on half the line. And then as I change the dimension of this line, it's actually changing the length of the entire line, see? Because I've dimensioned half of it, and so on. Now, if I want to do that today, I'd have to create a point, constrain the point to the midpoint of the line, and then dimension between the endpoint of the line and the point. So I'd have to, again, create extra geometry and create extra constraints. This way, I can just dimension to it. And it isn't limited just to lines. Let me put an arc between, let's say, here. And now I'm going to come in here and I'm going to put a dimension from there to there. So I can put a midpoint of an arc too. It's just the midpoint, not to the center. See, now when I go to move that one, see, it actually changes the size of the arc because I'm moving half the arc and it updates the rest of it. So I'm not saying this is a common way that you constrain things, but I'm sure there have been times when you really are worried about half of something. You're not really wanting to mirror something. You just want to control a larger object by controlling half of its size. And today you'd have to end up putting extra constraints in or revert to only doing it with a mirror. and so on. So this is just a little bit more control over it. Here's another thing that's of interest, that should be of interest to everybody. I'm going to put a dimension, let's say, on this arc here. And now I'm going to move that arc, let's say, over to here. You notice what happened to the dimension? You notice what happened to the dimension? The dimension now moves with the object. We used to leave the origin where it was, and then you had to remember to drag the origin over if you move something really radically. You know, all your geometry's over here and all your dimensions are on this end of the page because that's where you originally placed them. Now we're going to move it with the geometry. Also, you notice when I'm moving this, you notice it's the real geometry that's moving around on the screen. It's not the ghost. We leave the ghost behind. You notice the constraints move too, so as you move things, you can see what constraints are going with those curves. What's happened is that we suddenly realized that everybody out there has much better graphics displays than they had a few years ago when we started doing all this. So we're just sort of brought everything up so that it takes advantage of what's in your graphics cards today. So we aren't dragging the ghost around as often. We're leaving it in place and trying to drag the real geometry, which gives you a better feedback. Okay, I know you're going to like this one. Take yourself back to the first day of NX class, modeling class, and they teach you about the sketcher. And they say, well, the sketcher is really easy to use. All you do is draw exactly the shape that you want. You know, get all the proportions right, get it so it looks like what you want it to look like. I'm going to turn off the grid here so you can see better what I've done. Get this shape right, and then once you got everything correct, then go put the dimensions in. You know, so let's come in here and add a fillet. I'm going to put a 3-corner fillet in here, let's say from here to here, and bring it down to here. Yeah, we got one of those. Yep, okay, that's the shape I want. And then they say, then just go in and put the dimensions on it, and everything will be happy. So I say, okay, fine, I've got the shape I want. Let's go put a dimension in it. So I'm going to come down here, I'm going to put a dimension. It says 50 millimeters. I say, oh gee, I want this thing to be 100 millimeters. So I say 100, and this is what happens. Isn't it? Isn't that what happened? You did just exactly what the instructor told you to do. And that's what you got. Well, this is what will happen now in 11. Now I have this preference turned off by default. It's actually on by default. I have it turned off for demo purposes. So now when I go and put a dimension in here, and I say, gee, you know, it's 50 millimeters, I want it to be 100, so I type in 100, and this is what I get.
Nice.
Now, it works on the first driving dimension. So the first dimension that you add to a sketch that's driving it will cause the entire set of curves that are affected to scale up relative to what you just typed in. The second dimension, all bets are off. Now you're back to individually changing things. But that first one will maintain that relationship. And again here, as you notice, if I do start dragging this, you notice that the dimension stays relative to the line and not just stays up there where it was. So this is a new feature. Also, what we've done here, let's say I've decided, for whatever reason, I want to make this thing 75% bigger. And how would I go about making this everything 75% bigger? Now remember, I could go, I guess, and delete this dimension and type in 175. But let's say I already had this dimension on it as well. So therefore, I'm down to where I have I don't have that first driving dimension. And let's say a circle here. Okay, we have sketch groups. We have a new sketch group type called scalable. So I'm going to take that right there, and I'm going to grab the whole thing and make it a scalable group. See, so now it's scalable. Now what does a scalable group do? It's, I can just scale everything. Now it can be controlled independently. So let me actually come in here and make this horizontal. Okay, so it will behave better. So I can control this. So remember I said I want to make it 175% bigger? How would I go about doing that? Well, remember this dimension up here was 100. So I'm going to come here and I'm going to put a new dimension, and I'm going to say 175. because now that dimension is driving the scale. Now, once I say it's 175, all I'm going to do is delete the scalable group. Is over constrained. Oh, yeah, okay, it's over constrained. That's fine, because it has both dimensions on here. So let's get rid of one of them. But everything is scaled up 175%. And I still only have 2 dimensions on my sketch. Or you can just use the scalable group just as that, just as a variable for just changing the scale of something. That you might be as part of your part design. I have this some feature that is controllable just by expression, scale only. Or I could use it like this. I get to a certain point and say, oh gee, I wish that thing was 50% bigger. God, how am I going to change every single object in there to make it 50% bigger? Okay, make it a scalable group, make it 50% bigger, and unscale it. And so you can use it as a tool for that. So these are things. Now we also have a relationship browser in here. This replaces the old dialogue that used to be where you would go to edit and delete and so on and so forth expressions. So now what we have is constraints. Now I can list by curves, and you can see which ones are constrained, which ones are fully constrained, under constrained, or this one, which is this arc right here, has got no constraints on it at all. So that's why it's an empty circle. I can also expand each one of these to see the constraints that are assigned to each one of those objects. And then I can expand that again to actually see what the other object is that is constrained to, if there is another object. I can also list it by constraints and do it in reverse and say, open up a constraint and see which curves are associated with that particular constraint. I can do it by just single select. I just want that object. So now I'm looking at only the constraints associated with that object. Now we're working on an idea of being able to select here and, oh, okay, I'm in single object, that's why. When I'm in all objects, the idea is there's been a suggestion, particularly when I'm in the curve mode, being able to select here and have it highlight over here. We haven't quite got to that one yet. That was an idea that was kicked around during beta testing. It's a little more complicated, but it's being taken under advisement. And we also have here, which is that I can take this and let me see where it's at. That's a relationship browser. That's not. So you can also do it there. And there's also where I can, it might not be in my version, where we can take it out into the expression browser, which is different. Okay, so that's sketching. Okay, let's look at some enhancements in assemblies. So let's go, oops, get out of my sketch and go to my favorite part. This is my favorite part. Remember, I'm a machine designer. So I use this part all the time, even when I'm in front of automotive and aerospace people, because it offends them equally. Being a machine designer, though, this is the kind of stuff we dealt with. So anyway, I have this part, and I've got two arrangements in here. I have closed and open, which is usually the condition you have with valves, either they're open or closed. But occasionally you might want to have something halfway in between. Well, with arrangements, you're either stuck with a limited number of arrangements. If it was a 50%, fine, I could put it halfway. But if I wanted it infinitely variable, I've got to get rid of my arrangements, or in this case, remove the arrangement-specific constraint, which was that. So now I can come in here and just simply grab the arm and move it, so I can move it anywhere I want. The problem is, I want to stop at closed and stop at fully open, but allow me to move it in between. Well, today, about the best I could do, you saw Sam talk earlier about requirements. I could put a requirement into this model saying, put an angular measurement, put a requirement that says if it's less than 0 or more than 90, yell it. It won't stop me from doing it, but a little warning will come up and it'll fail the checkmate, and so on and so forth. But it doesn't really prevent me from doing it. I would really like to have the system only limit my motions. So, what I have here is we have a new constraint, not a new constraint type, but a modification to two existing constraints, angular and distance. These are the two constraints that are driven by numerical values. All the others are driven by other relationships, but those two are driven by numbers. So I've created what we call a driven constraint. So now it's active. So what happens there? So now I'm going to go out here and I'm going to pick that same arm. I'm going to do that same motion, but watch what happens now. When I get to fully closed, it stops. When I get to fully open, it stops. But I can put it anywhere in the middle and save it. Well, how does that work? Well, let's take a look at this driven constraint. So here's the constraint dialog for an angle. And this is what we have here. Now, and by the way, you're going to get more and more of this, where we put up a little paragraph explaining what things are inside the dialog. Used to be you had to hit the F1 button unless you're idea. Any X-Ideas users here? Yeah, you guys use your F1 button for something else. But UG user, old UG users, your F1 button is your context-sensitive help. So you hit the F1 button, a dialog would come up, and hopefully somewhere in that dialog, that page of help, it would tell you what those options are for. Now we're going to try to describe those options right out there in the thing. So if you read this, it says, when enabled, the value is defined by the user. That's the old way. You know, you typed in the value, that's what it was. Now it says, when disabled, the value is driven by the system, which could be other constraints or some other scheme. In this case, I put a limit. Now it isn't really 0 and 90 because of the way my angles are set up. It's 180 to 90, but you get the idea. It's a 90-degree range of motion as an upper and lower limit. Now I can have one or the other, or both. In the case of angles, having only one would be kind of stupid because that meant you could go all the way around, and that's not going to win you anything. But in this case, I have an upper and lower limit of basically 0 and 90 degrees, and that's the limit that I can move it. So think of the design intent you can now put into your models. And remember, this link could have been driven from something else. So that something else would move until it reached this point, and then it would stop. And that's just the way it would be. So you can now model the logic of the motion as well as the physical characteristics, the motion of it. You can actually put starts and stops. Now, this also works with linear. So I have this example here where I have this part, and I'm going to move it, drag it back and forth, see, from one end to the other. Okay, nothing real exciting about that. So let's actually go in and make this the work part. Come up here, it's 150 millimeters long. I'm going to make it 200 millimeters long. Update. Come out here, bring it back to the assembly. Now move it. Now it's this one. Well, how did that happen? Where did the limit come from? Well, in this case, the limit, let's go and look at the expression here. Here's the constraints. There's my driving, driven dimension, and go look at it. In this case, it's linear. And I have the upper limit set to 170 millimeters, which if I look in here, it's a measurement. So I actually took a measurement between the centers, this center and this center over here, right here. I took a measurement between those two centers, and that's the value that I inserted into the limit. So the limit can be a variable. So as parts change, and it could be a simple measurement, that you can now control these limits, where in this case I'm simulating a physical limitation, where in the first model it was strictly a logical limitation. Nothing preventing that valve from going all the way around. I just only wanted to stop it at fully open or stop it at fully closed. Here I'm mimicking a physical limitation. And I use a measurement so as to adjust it so as the part changed in size, that physical limitation changes, so therefore the constraint changes. So think of what you could do now with assemblies. That would be interesting.